welcome back to Math Mini Lessons. My name is Sarah, and in this video we're going to break down the August 2025 Algebra 1 Regents exam. Let's start with the answers for 1, 2, and 3. Our answers are 3, 3, and 2. Check and see if you got the same things. Stay here if you need to break down. With number 1, we have which expression is equivalent to 100x squared minus 16. And the first thing I notice is that between these two numbers, 100 and x squared, those are squares. Like, I know that 100 is a square number, and I also know x squared would be a square because x times x makes x squared. And 16 is also a square. So in my head, I'm doing this. I know that this is true. I know that this is true. And I know that this is true. So I'm going to use a process called difference of two squares. In other words, when you see two squares, a binomial, and they're being subtracted, I can express them like this. 10x plus 4, 10x minus 4. And that is going to give me 100 squared minus 16. And if you want to see if that's actually true, we can use an area model so I can put the numbers in. Here's 10x plus 4. Here's 10x minus 4. In the first box, 10x times 10x is 100x squared, which is exactly what we had here. 10x times 4 is 40x. 10x minus 4 is minus 40x, and minus 4 times positive 4 is going to give me negative 16. And the one thing I want you to notice is these two over here give me a zero pair. They're going to cancel each other out. 40x minus 40x is just going to give me 0 x's. So that's going to leave me with 100x squared minus 16, which is what we had here. And you'll see our choice right over there. All right, but the big key was recognizing that each term can be squared, and we can find the square root of them. Josie has $2.30 in dimes and quarters. So I don't know how many dimes she has. I know dimes are 10 cents. So here are my dimes, plus however many quarters we have times 25 cents. Is going to give me $2.30. She has 2 more dimes than quarters. So she has 2 more dimes than quarters. Okay, so the number of dimes is equal to the quarters plus 2 because she has 2 more dimes. So if I wanted them to be equal, I would have to have quarters plus 2. Which equation below can be used to determine x, the number of quarters? So x has to be the number of quarters. So wherever I had a Q, I'm just going to put an X. And just for consistency, whatever I had for D for dimes, I'm just going to put a Y. So how could I rewrite this? Well, this relationship is going to be the important part right here. My number of dimes is equal to X plus 2. So I'm going to take this, or actually I'm going to take this term, the x plus 2, and I'm going to substitute it in for y. So that I'm going to have 0.10 times x plus 2 plus 0.25x is equal to $2.30. Okay, because in the problem, that's one way I can easily make a new expression, a new equation, and it's just by using a substitution because of what I know here. And that's where I got 3. So you can just see they just switched the terms around, but they had let me put my little pointer up. They had 0.25x times 0.10 times x plus 2 equals $2.30. Let's look at number 3. If g of x is equal to negative 2x plus 16, then g of negative 3 is equal to, all right, so let's put in our expression, negative 2x squared plus 16, and we want to know when g of negative 3. So in other words, when I see an x, I'm just going to sub in a negative 3. So negative 2 times negative 3 squared plus 16. I'm going to start with my exponent. Negative 3 times negative 3 is positive 9. So negative 2 times positive 9 plus 16. Negative 2 times 9 is negative 18 plus 16. This gives me negative 2. And there's our answer. All right, hit pause and jot this down into your notes. Check and see how you did. For every single one you had correct, that would be worth 2 points. Let's look at the answers for 4, 5, and 6. We have 2, 1, and 3. Check and see how you did. Remember, give yourself 2 points for every single one that was correct, and stay here for ones that if you had anything incorrect. With the first one, number 4, what are the zeros of f of x is equal to x squared minus 8x minus 20? So this is a trinomial. So I'm going to factor this. And to start this off, because I'm going to turn it into 2 binomials, I'm going to have x and x. I'm going to find the factors for negative 20. So I'm going to put negative 20, and we're going to think, what are all the factor pairs that would make just 20? So I start with the biggest one, 1 times 20, 2 times 10, and 4 times 5. I know I'm done because my next factor would be 5. And now I have to think, if I were to add any of these two together, which one of them is going to be positive and one is going to be negative? Which one would give me negative 8? So one is positive, one is negative, and I want negative 8. The only way I can kind of get that is with these two numbers. I can see a difference of 8 here. So the difference between 2 and 10 would be 8. But I want negative 8. So which one should be negative, my 10 or my 2? Well, my 10 should be negative because negative 10 plus 2 is going to give me negative 8. And those are my factors. So here's negative 10 and here's plus 2. And that's how I got my answer number 2. All right, so the key to this is 1, recognize it's a trinomial to the second degree, and then you're going to use your factors for the third term. So you're going to get something that looks like this. And you're going to look for the factors of your C term. And then you're going to look to see how can your factors make a sum, have a sum of B. That's your goal. Let's look for number 5. Which point lies on the graph y equals 3x squared minus 1/4 x, negative 1/4 x plus 3. Okay, so I'm going to look at the points that we actually have here, and I find like the best way for this is actually just to substitute and to try them out. So I normally would just take my scrap paper and I will put it into 4 quarters. And so my paper would kind of look like this. And I will put 1, 2, 3, and 4 and actually try them out. So I'm going to start with my original 3x squared minus 1/4 x plus 3. And I'm going to try with number 1. My points are negative 2. So wherever I see an x, I'm going to put negative 2. So 3 times negative 2 squared minus 1/4 times negative 2 plus 3. And my y would be 15.5. All right, and now I'm just going to simplify this out. Negative 2 squared is just 4, positive 4. Negative 2 times negative 1/4 would be, well, negative times negative is going to be a positive 2/4 plus 3. We're going to simplify all of this out, and I'm going to get 12 plus 2/4 is the same thing as a half. In this case, I'm just going to, because this is a decimal, I'm going to change it to a decimal. So 0.5 plus 3. And so I have 15.5. So this one worked perfectly for A. It's not always going to work. It may not always be the first one. But if this one wasn't it, then I will go to the next one and I will do the same substitution. Wherever I see an X, I will put my X coordinate. And wherever I saw my Y, I would put my Y coordinate. Let's go down to number 6. Given f of x is equal to x squared, g of x is equal to 8x minus 15. graphed on the same set of axes, which values for x would make f of x equal to g of x. So this is what I want. So I'm going to set those equal to each other. X squared is equal to 8x minus 15. Okay, I want to get it into that form that we talked about before, the one that looked like this. So what I'm going to do is I'm going to subtract. I'm going to move this one over. I'm going to do minus 8x. And I'm going to make this a positive 15. Why? So that I have x squared minus 8x plus 15 is equal to 0. Because this is going to cancel out and this is going to cancel out. And on the other side, I'm also going to do the minus 8x and the plus 15. All right, so that's the trickiest part. Now we're going to do the same thing we did with number 4. I'm going to think, what are my factors of 15 that are going to add up to negative 8? So my factors of 15 are 1 times 15 and 3 times 5. I need those factors. Now this is a positive. So my factors, the only way I can multiply things and they become a positive is if both of them are positive, like a positive times a positive, or if it's a negative times a negative. So I'm looking at this, which are the only ones when I add them up together that I'm going to get an 8? Well, if I add these two together, I'll get 8. So now you have to think, how could this be? Can this become negative 8 if both of them are positive? No. Can this be a negative 8 if both of them are negative? Yes. So then those are my two factors. Negative 3 plus negative 5 is negative 8, and negative 3 times negative 5 make 15. So I'm going to put my factors in there. X minus 3 and x minus 5. Now that I have this part, I still have these equal to 0. So I have a little bit more solving to do. So I'm going to set each of these equal to 0. X minus 3 is equal to 0 and x minus 5 is equal to 0. Now why am I doing that? Because I know that anything multiplied by 0 is going to be 0. So if this somehow became 0, whatever this is times 0 would give me 0. If this one was a 0, whatever this is times this would give me 0. So I'm going to set both of these up separately to 0. And when you solve in the first one, x minus 3 equals 0. So I know x is equal to 3. And x minus 5 is equal to 0. So x is equal to 5. And there's our answer 3. This one took a little bit more work, but we're able to do it. Another way you could solve this though is by actually putting it into your graphing calculators. Let's look at my calculator. I'm just going to go into the y equals and I'm going to put x squared for the first one, and let's go down to the second one, and you can put 8x minus 15. And if you were to graph them, you would look for the point where both of them actually hit each other. So I'm going to want the table, and on the table you're going to look to see where do you find the value of x where they both have the same x and y. Like, where do you see it in both? So I'm going to move over and I'm looking for where my y's are the same, and here you have it. At when x is 3, they both get a 9. So x equals 3, that's the first one we talked about. And what other x value has the same value here when x is 5? My y's are 25 and 25. So those are our answers. When x is 3, my y's are the same, so these are the same point. And when x is 5. So there's two ways we can solve this. We can do it with graphing and looking at the table, or we can do this algebraically. Hit pause and jot this down into your notes. Let's look at the answers for 7, 8, and 9. The answers are 4, 4, and 4. Same answers all the way around. We'll start with number 7. Which trinomial is written in standard form and has a constant term of 5? So in standard form means that they're going to descend. So my exponents are going to start with the biggest one on the left, and then I'm going to get smaller and smaller and smaller as I go down, and at the end I'll have some type of constant. So that's going to happen. And then they're saying my constant term has to be 5. So just looking, I'm going to look to see which one has a constant term of 5, and these two do. So I'm just going to eliminate 1 and 3 automatically. And now I'm going to look at my other terms and think, are they in standard form, meaning they're descending, they're getting smaller? And my exponents are not getting smaller, they're going from 2 to 4, so no. My exponents here are going from 5 to 2, so yes, that is descending. They're getting smaller, and my constant is 5. So there's my answer 4. For number 8, when solving x squared plus 6 equals negative 8 for x, a student wrote x squared plus 6x plus 8 is equal to 0 as his first step. So what property is that? So I have to think what's happening here. The kid started with this, x squared plus 6x is equal to negative 8. And then this stays the same, this stays the same, but all of a sudden he has a positive 8 is equal to 0. So what did that kid do? How did he do this? Well, the only way this would happen is if he actually added 8 to both expressions. So that this would give him a 0 pair, and it would leave him with the 8 over here. So what property would that be? It's definitely not the 0, it's not a 0 property of addition. It's not commutative, and it's not associative. It's the addition property of equality. Why? Because I'm keeping my equation equal. That's the big goal there, is staying equal on both sides. But I'm using my adding, I'm adding integers to make 0 pairs. So I'm adding integers to make 0 pairs, and the equation stays equal. That's why I call it the addition property of equality. Let's look at number 9. The table below shows the input and output of 4 different functions. Which of these shows a linear function? So when I think of something that's linear, whether it's positive or negative, it is changing, it has constantly. So it has a constant rate of change. Meaning as my x values continue, as I continue to move in this direction, my y's keep changing by the same amount each time. So it has to stay consistent. So when you're looking at your values here, look to see, and these are all going by ones, look to see if the differences here are staying consistent. So for example, from 6 to 1, I'm going down by 5. I'm going to use a different color. So I go down 5. And then from 1 to negative 2, I would have to go, this is not consistent. If I subtracted 5 again, I would have been at negative 4. But instead I'm at negative 2. So this first one is not it. So I move to the next one. 3, I'm going down 1 to get to 2. I'm going down 1 to get to 1. Down 1 to get to 0. But now I'm going plus 1. So this one, not it. And now I'm going plus 1 again. So this one went down and then went up. So that one's not it. Now I look at the third one, and from 1 to negative 2, I'm subtracting by 1, up, and then now I'm subtracting by 2. So already not constant. So we'll look at the third one. From negative 11 to negative 7, so I'm adding 4. Negative 7 plus 4 does give me negative 3. Negative 3 plus 4 does give me 1. 1 plus 4 does give me 5. 5 plus 4 does give me 9. So this one is the one that has a constant rate of change, because I can see it here. The constant change in my y values. So my answer would be number 4, j of x. All right, hit pause and jot this down into your notes. Let's look at our answers for 10 and 11. Our answers are 2 and 2. See how you did. Give yourself 2 points for every correct answer. For number 10, what is the solution set to the equation 3x squared is equal to 24x? Alright, so we're going to start by just writing out this equation. 3x squared is equal to 24. Oops, I didn't write the 4. X. And what can I do with both sides? I can definitely divide, because I want to keep them equal. So I'm going to divide both sides by 3x. Because I see that as a common factor in both. And when I do that, on the left side, I'm left with just x. And on the right side, 24 divided by 3 is 8. And my x's just become 1. So 8, x is equal to 8. Now, another way, is there any other way I could make these two equal to each other? And this one's kind of like an interesting way to think about it, because I know I see my answer here at number 1. What if x was equal to 0? So if 3 times 0 squared is equal to 24 times 0, I would end up with 0 is equal to 0. So that one's a little bit tricky, but there you have it. Our answer is 0 and 8. Let's look at number 11. The table below shows the radioactivity level of a substance after given time t. What is the average rate of change in radioactivity between the interval when 1 is less than or equal to t is less than or equal to 3? So I'm really looking at from 1, when time is between 1, because it could be equal to 1, and it could be equal to 3. That's why I'm including it. If that wasn't underlined, like if it was just this, then I would only pick the 2. But because there says it could be equal to 1 and equal to 3, I'm highlighting those as well. All right, so we're looking for rate of change. And for that, we're going to use our rate of change formula. I want to look at the change in y over the change in x. So from here to here, how much did it change? So 2.5 minus 10. And in the y's, from 3 to 1, how much did it change? 3 minus 1. Well, that was the easy one. That one's just 2. If you got a little stuck doing 2.5 minus 10, you could use your calculator, but it'll give you negative 7.5. Again, if you're unsure, just go to your calculator. 2.5 minus 10. There you go, negative 7.5. All right, so negative 7.5 divided by 2. I have to do that part. 2 goes into 7 3 times. And again, I could just use my calculator for this. 2 goes into 15 7 times. And 2 goes into 10 5 times. So my answer would be negative 3.75, which is my answer too. And again, you could have just done the same thing here, negative 7.5 divided by 2 to get negative 3.75. I just like to, I don't know, there's some problems where I just like to do them manually and just use my calculator for checking, but you have that option as well. All right, hit pause and jot this down into your notes. Let's look at the answers for 12 and 13. The answers are 1 and 4. Check and see how you did on these. Now, for number 12, this is a linear regression problem. And this is definitely going to be one of the 4-point questions at the very end, so we're going to use our calculators for it. Fred recorded the number of minutes he read each day from Monday through Friday. His results are shown in the table. So here's the table. What is the correlation coefficient to the nearest thousandth and the strength of the linear model? So what we're going to look for is we're going to get an equation that looks like this. Y equals ax plus b when we do this on the calculator. And it's going to give me our R, which is our correlation coefficient. And that's what we want. And if that number is either going to be a number that's close to -1, or it's going to be a number that could be close to 1. So if it's all the way closer to the negative, then we can say, like if it starts moving in this direction, it starts to have a strong negative correlation. The closer it gets to -1, the stronger it is. The closer it gets to +1, you get a strong positive correlation. And if it's close to 0, then you have no correlation. So that's the way we're going to think about this. So what you're going to do is you're going to go into your calculator. You're going to hit Stat. You're going to press 1 for Edit. And you're going to put your data in. Okay, we're going to just type it in there. On this side we have 1, 2, 3, 4, and 5. And on the other side we have 12, 16, 19, 27, and 29. So now we have our data in there. So we're going to go back to Stat, and you're going to go to hit Calc and go down to number 4, which is our linear regression. Hit Enter. We want everything that was in that list, that first list, L1. So hit that again. Hit, L1, L2, calculate, and boom, you get this really important information where it's telling us our A is equal to 4.5. So here's my equation. A equals 4.5x, and our B is 7.1. The other part we want though is our R. There should be another part that says R squared and R. So I'm going to go back a second and make sure that we have everything in there. We're going to look at our setup. Make sure you tap diagnostic twice, like enter, so you should see this where you're going to get this message, diagnostic on. Now we're going to go back to Stat. We're going to go back to calculating because our list is still there. Go down to number 4, enter again. Go down to calculate, enter. And boom, now we have our R. And you can see we have R is equal to 0.983. So let's put that in. R is equal to 0.983. And that is, we're going to the nearest thousands, the 3 and then 8. So I'm going to round this up to 0.984 is our R. So because this number is very close to 1, to positive 1, I can say that this is a strong positive correlation. And I just have to look to see, and here you go, 0.984, that's our correlation, and it is strong. Okay, so if you run into that same issue I did where you weren't seeing the R squared and the R, again, you have to go into second and category and scroll all the way down to diagnostic on and hit that twice. That can happen. All right, let's go down to number 13. Given f of x is equal to x squared, which function will shift f of x 3 units? Okay, so for this, I have to know the form for when for doing this. And how do I know when something is moving 3 times? So what is going to happen to my x? So to make it move to the left, it's going to be a positive number, and to move to the right is going to be a negative number. So if I want to move 3 to the left, I'm going to have positive 3. So x plus 3 squared will move and shift my f of x 3 times to the left. All right, hit pause and jot this down into your notes. Now, another way of looking at this, if you're not sure about what the shifts are, what you could do is you can go into your y equals, and you can literally just put in, here's x squared as your first function, and you can just type in the other ones just to see what would happen. So you could have put this, for example, ax squared plus 3, and then graph them. There's my original and there's the other one, and you can see that in this one my red was the second one. All it did when I come back here is this one went up 3. So in the second one, you can kind of imagine if it's -3, it's just going to go down 3. So let's see if that's true. let's make this a -3. Graph it. Here's my original. And look, it went down. So it went down 3. So there you go. This is just another way. If you're not sure what the functions are, you could actually try these out. So let's try the second one, 3 and 4. So we're going to put our parentheses. X. Let's clear this one off. Parentheses. X -3. Close parentheses. Squared. Graph it. And see, when we did -3, notice my blue shifted 3 to the right. So it went this way to the right 3. And so I'm going to go back to my Y, and you could also test it. And you can make this a +3 squared. Look at the graph. And so when I have X +3, it moves to the left 3 times. All right, so that's just another way. If you're not sure what the shifts actually are, you could actually just graph the parent first, f of x. In this case, it was just x squared. And then you could just try the other shifts to see like how is it moving. And you can just determine from there. All right, here are the answers for number 14. We have 2 and 1. All right, let's look at number 14. A class of 20 students were surveyed to determine the number of pets each student owned. The data are represented in dot plots. Which statement about the data is correct? So notice that these are just asking me about central measures, mean and mode and things like that, mean and mode. And so what you could do is, at least we can determine just by sight what the mode is. Our mode is 2, is our most frequent, like 1. We could figure out what the median is by just counting towards the middle. So I can just start crossing out 1, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So our median is also going to be 2. And if we have to go into the mean, we can calculate all of them. All right, so we can put everything together and let's see, 0 plus 4 groups of 1, that's just 4. 1, 2, and now all I'm doing here is counting. So we did those already. I have 1, 2, 3, 4, 5, 6. So 6 groups of 2. That's going to be 12. I have 4 groups of 3. I have 3 groups of 4. And I have 2 groups of 5. So we're going to add all those together. So 4 plus 12 plus 12 plus 12 plus 10. So 4 plus 36, that's 40, plus 10 equals 50. 50 divided by the 20 numbers they gave us is going to give me, let's see, 20 goes into 50 2 times, 2.5 times. So 2.5. All right, and again, you could have just done this with your calculator if you needed to. I just did it kind of fast by just adding the numbers in there. So here are my stats. Now I just have to see which ones, what they have here. And they're asking me which ones are the same. We already did those, the median and the mode. And done. All right, let's look at number 15. The range of f of x is equal to the absolute value of +2, x plus 2, minus 5. And I want to know what my range is for this one. So for this one, we have to go into our graph. So we're going to go into our y equals. I'm going to clear that as well. And I'm going to put into our absolute values. So where do we see absolute value? Looking. All right, I couldn't find absolute value, so I actually had to look up where I would find it, and I have to hit the math button. And then I can go over to number, and boom, for number 1, there is my absolute value. So now I can put in, see, doing these videos actually helps me remember things on a calculator that I haven't done in a really long time. So here's my x plus 2 minus 5, and we're gonna graph it. And so what are you seeing and what are you noticing about the y value? So when I'm thinking about the range, I'm noticing my y values, and when I'm tracing it, I'm noticing, oops, there we go, that my y's are all above -5. So it never gets below -5. So for here, my range, I'm thinking of my y values, y has to be greater than or equal to -5. Okay, so hit pause and jot this down into your notes. And now you also know how to find the absolute value symbol on the calculator. We have to hit math and then go to numbers. Let's look at the answers for numbers 16 and 17. The answers are 3 and 1. Check and see if you had the same things. All right, number 16 has to do with different exponent rules. So let's kind of just review them over here, what kinds we have in this problem. We have the power rule, which has, like, if you have the same exact base and different exponents, you're just going to add those together. Why? Because think of it as if like you're expanding something. So if I had like something to the third power, I'm going to use this space, times the same thing to the second power. If I expand this, I just have a times a times a 3 times, and then a times a 2 more times. So all together, I have a to the 5th power. So that's all the power rule says. That's why number 1 doesn't work, because those two should be added together, not multiplied. Then you have the power of powers rule, and that one says that if you have an exponent next to the number, but then next to the base, and then you have that little parentheses part on the outside, what you're going to do is you're going to multiply those two together. Same thing if you were thinking of something like a to the 2nd power, and then it's going to go to the 3rd power. This is pretty much like saying I have a to the 2nd power times a to the 2nd power times a to the 2nd power. And we already know with this type we're going to do, we're going to add all those together to get a to the 6th. As opposed to here, where if I just multiply these two together, I would get a to the 6th. That's why the second one doesn't work, because here you're adding those two exponents together. And then you have the third one, the power of products rule. And that's where you have two numbers being multiplied and there's an exponent. And what this one says is that you have to find the exponents for each one before we multiply. Just like our order of operations, you're going to do the exponents first before we multiply. So I'm going to do a to the m power and b to the m power before I multiply them together. So I think that makes sense when we think about it in order of operations. And that's why this one is correct. And C4, the reason why that one is wrong, well, one, our bases aren't the same. So I can't just add those two exponents like the power rule. All right, I'm going to just erase this part down here, so I have space for number 17. And in number 17, we're rewriting a formula. The formula for the area of a trapezoid is A equals 1/2 the height times base 1, base 2. And I usually tell kids we're going to find the average of the bases. So we add base 1, base 2, divide that by 2, and then multiply it by a height. But because all these numbers are being multiplied, the order doesn't necessarily matter. But in this part, what we want to do is we want to find the height. The formula for the area of a trapezoid is the height h of a trapezoid may be expressed as. So all we want to do is figure out, go from this formula to h is equal to. Okay, so we just want to isolate the h. So think about this here. I have 1/2 times the height times base 1 plus base 2. And all that is equal to area. I'm just going to put that on the right side. And the only thing I want here is this. And they're all being multiplied together. So if this was just something as simple as 3x is equal to 5, you know you would just divide this by 3. You would divide both expressions by 3 to isolate the h. You're going to do the exact same thing here, where in this case, let's get rid of this part first, the b1, b2, the sum. So I'm going to do that to both sides. So now I have 1/2 h is equal to a, again giving myself a little bit more space here, a divided by b1 plus b2. And now you just have to think, what would you want to do? Like when I have a half, what could you do? You can either multiply, and this is probably the trickier part. Like if I had 1 times x, I'm going to just make the numbers easy, times 5. You could just divide this by a half. That could work. And then you're dividing this part by a half. What does that mean? You're going to do 10, let's see, divided by 1/2. You're going to rewrite this into 10 times 2/1. So we were multiplying by the reciprocal. The other thing, you see how that's happening here? So this is one thing you can do. You can just multiply it. Another thing you could do when we have a fraction is you can just multiply it by its reciprocal to turn that into 1. So that's where, if I multiply these over here, I would still end up with x. So you can either divide the fraction by itself or you can multiply it by its reciprocal. Both of those work algebraically. So when I look at this part here, I'm going to decide to multiply it by 2/1. Okay, it's still going to leave me with h because 2/2 is the same thing as 1h. So I'm going to just leave it as 1. And I'm going to do the same thing to the other side. I'm going to multiply it by 2/1. And that's why I'm going to have 2a over b1 plus b2. This type of problem is just seeing, do you know how to isolate variables? Do you also know how to deal with fractions? And that is it here. So I am going to let you know that when we have this 1/2h, your two pathways are either to do 1/2 divided by 1/2 on both sides, or you can multiply by the reciprocal. You get to decide which one makes more sense. I personally like this one more. Mathematically, it's going to do the same thing. When you divide a number by a fraction, you're going to turn it, you're going to do the whole keep, change, flip, and you're going to end up multiplying by the reciprocal anyway. All right, hit pause and jot this down into your notes. Let's look at the answers for 18 and 19. We have 1 for 18 and 3 for 19. Let's go through number 18 together. We have 3 functions, and they're asking us which functions have the same y-intercept. Now, here, at least, the good thing is we can see the y-intercept pretty well in this one. When x is 0, we know y is -3. So we're just going to check to see, I'm just going to see, do either of these have these coordinates? So we're going to try that out. I'm going to try f of x first. And we're going to do f of 0 pretty much to see if it's true. So I have negative absolute value when x is 0 plus 2 plus 7. So we do what's in the absolute value first. 0 plus 2 is 2, so that's just a positive 2. All right, so then this turns into a -2 because the negative is on the outside, plus 7. This is equal to 5. So when my coordinates for here would have been 0, 5. So we definitely know that f of x and h of x do not have the same intercept. Now let's look at the other one. We have g of x, so we're going to try the same thing when g is equal to 0. So I'm going to put in our parentheses. Let's put in, make this a 0. 0 minus 3 squared minus 4. Okay. 0 minus 3. I know that's only going to be -3. So -3 squared minus 4. -3 squared is going to be positive 9. 9 minus 4 is going to give us 5. So in this case, we would have 0, 5. So I do notice something. I noticed that these two have the same. So the f of x and the g of x. So this one was kind of interesting. All I had to do was, I wanted to know the y-intercept. I just created a case when x is equal to 0. This one at least was easy to see. And then here I just did the same thing. I just tried it out. And I got what my other coordinate would be. My b would have been 5, and the same thing happened here. And then it was easy for me to see which two had the same y-intercept. All right, let's look at number 19, and we have the sum of x plus 7 squared and x minus 3 squared. I'm going to write this out. Now, for some of us can kind of see, like when I see this form, x plus 7 squared, we get that this is going to be a trinomial x squared plus 14 plus 49. Now, if you don't see that, that's okay. If you didn't get that at first, you could have just expanded it out by just doing x plus 7, x plus 7, and then you will get x squared, 7x, 7x, 49. And then you can see it's x squared plus 14x plus 49. Most people can see the 49 pretty quickly because it's just 7 squared. And some of you probably said, oh, if I also did 7 times 2, I would get my middle. So that's also true. So that's why some people just get the form really fast, or they're just doing the square of the last part, this part in here, and then just multiplying that number with the exponent. So let's try to actually apply that with the second one, and then we'll verify it. So here you have x minus 3 squared. So we know we're going to get x squared, and you know you're going to get 9 because negative 3 times negative 3 is 9. What do you think that middle term is going to be? Well, if you tried that multiplying part, 2 times negative 3 is negative 6. With the x. Don't forget the little x there. We forgot that. All right, so now let's try it out. X minus 3 times x minus 3, and you get x squared, negative 3x, and positive 9. So yep, these two are being added together, so you're getting x squared minus 6x plus 9. So that convention does work, but if you're not always sure, you could always just use your area models and work them out. All right, so now they're just asking for the sum, so let's add these up. So I'm going to add them up vertically. I'm going to start on the right. 49 plus 9, that's the easiest one. That's 58. Positive 14x minus 6x, that's going to leave me with 8x. And x squared plus x squared gives me 2x squared. And there is my answer, 3. So what I love about these problems is that you don't have to always know everything, all the rules and conventions. You may not have them memorized, but there are still ways to work it out with the algebra. Because like I said, not many people are going to remember, oh, I can just do x square this and square this, and then just do 7 times 2 to get my middle term. Not everyone remembers that. And that's okay. The point is, memorizing random things doesn't show you know the math, but you could actually use the math to find the answer anyway. Okay? So hit pause and jot this down into your notes. Let's look at the answers for 20, 21, and 22. We have 1, 3, and 4. Check and see how you did. 2 points for every right answer. All right, we're going to start with the first one, which is what is the product of 2 square root 10 and 3 square root 2. So this is the problem we're trying to work out. 2 square root 10 times 3 square root 2. And there are 2 pathways we can do about this. You can either factor in the beginning, or you can factor at the end. Which would you rather do? I personally like to get the factors for that number and the square root sign in the very beginning. So I'm going to do 2 times, what are my factors of 10? I have 5 and 2. So I get 2 times square root 2 times square root 5 times, we have 3 and square root 2. Now when you do this, I notice that I have square root 2 times square root 2, which is just going to give me 2. So now I have 2 times 2 times 3. I'm going to put all my whole numbers in the front, and there's my square root 5 at the end. 2 times 2 is 4. 4 times 3 is 12. Square root 5. Or you can do your factoring at the end. So 2 times square root 10 times, oops, let me put this in there, square root 3 times square root 2. So why did I put this under? Sorry, that should not have been in there. So I can just multiply this way, and I'm going to put these two together. 2 times 3, square root 10, square root 2. So that would be 6, and these together would make, look at, this is why I kind of find this silly. I get square root 20, and I have to find the square. I have to break this up more again anyway. So what are my factors for 20 when I keep breaking them down? Let's see, I would get 10 times 2, and I still got to break down 10 some more. 5 times 2. So this is kind of why I don't like doing it at the end, because I get 6 square root 5 times square root 2 times square root 2. Here we go, I can take that 2 out. So that would now be 2 times 6 square root 5, or 12 square root 5. That's why I don't really like doing it this way. Another thing some kids do when they're looking at this is they can kind of think, I'm going to erase this for a second. They can think, are there any square numbers in 20? Does 20 have any square factors? And they might go, yeah. 4 times 5. 4 is a square number. Okay, the square root of 4 is 2. So 2 times 6, square root 5, or 12 square root 5. Either way, I kind of feel like doing it at the end is more work than just splitting it up in the beginning and then multiplying. But you get to decide. It's up to you to decide which method you would rather do. Pick the one that makes the most sense and the one that you think you can solve better. Number 21, you're just subtracting. I think I have enough room for this one. So let me just move this over. So I like to stack things. It says when 6x to the third power minus 2x plus 8 is subtracted from, that's important. So I'm going to take it from the other one. So I'm going to put this on top. 5x third power plus 3x minus 4. And now I'm going to subtract my whole part over here. I'm going to subtract 6x squared. And I'm going to put this over here because I'm subtracting all of these and thinking about them. I need to make sure that now this is going to be a positive 2x, because I'm literally doing, how do I want to put this? If I'm subtracting 6x squared minus 2x plus 8, I need to distribute this negative 1. I got to distribute it. So that's going to give me negative 6x squared cubed plus 2x and minus 8. Okay, so I want you to see what's happening here because I need to subtract this entire part. So now I'm going to put that there, and you can subtract. So on the end I have negative 12, 5x, and 5x to the third power minus 6x, it's going to be negative 1. Okay, so which one is that going to leave me with? Number 3. All right, but the key to this one is knowing that I'm taking this from this, so that my order is going to matter. And then you had to remember that you had to distribute that negative 1 to turn it into a subtraction problem. So those two things had to be true. All right, I'm going to give myself a little space and room over here as well. And let's look now at number 3. We want to know which of these is a function. So the easiest ones to look at, I like using the graph first because I'm going to do the vertical line test. And I'm just going to go straight down and see, does it pass? This passes here. This does pass because this is an open. So it does not include that point. And it only passes through the second one. Same thing here. So this part passes. And at the y, this part passes. Okay, so number 3 is a function. Now let's look at number 2. none of these repeat, so there's only, every time I have the x, when I see that none of them repeat, I'm good. This is going to be a function. 3, 4, 5, 6. We're good. Now I want to see the same thing with number 1, so I'm going to make that same little part. So I'm going to have for my x's, and here are my y's. I have 0, 1, 2, 3. So good, nothing is repeating. So 0 is going to go to 1, 1 is going to go to 2, 2 is going to go to 3, and 3 is going to go to, oops, I wrote the wrong number, 4. So this is also a function. So all 3 of them are functions, and I go here. This is super important because if I were to graph it, and that's kind of why I like to think about it with the vertical line test. If I were to graph these on a line, like when x is 0, 1, 2, 3, I'm only going to have 1 point for each one. Same thing with this one here. When x is 3, 4, 5, and 6, I'm only going to have 1 point for each one. So it's always going to pass my vertical line test. Okay, hit pause and jot this down. Oh, wait. The way I would know this was wrong, like let's say I had another 0 and it gave me a different number. So that's how I would know if it would fail. If there was one of these repeated, if I get a different value for y, then I know it would fail. Okay, hit pause and jot this down into your notes. Okay, let's look at 23 and 24. These are the last of the multiple choice questions. You have 1 and 4. So again, look at all your multiple choice. How many were you able to get right before looking at the breakdowns in this video? Your goal should be to get at least half of them, like you want to get at least 12 of them, or close, 10 to 12, because that will give you most of the points you need to pass. If you get 10 right, that's 20 points. If you get 12 right, that's 24 points. That gives you a solid half. And if you're aiming for that 4, that 5 score, then obviously you want to get at least you want to get closer to 16 to 20 of these correct. And I hope this video will help you with the skills that you didn't get, so you know how to practice them in with the other practice problems. Okay, so in 23 it says we're using the substitution method to solve this systems of equation. We just want to know what the first step would be. All right, so when I look at these here, I need to figure out what I would substitute. I want to actually change this around, because if I'm substituting, I need to get it to be either y equals or x equals. That has to be the thing that happens. That's going to be the goal. So when you think about that, and let's actually separate those two out. Here's y equals, here's x equals. So if I have x minus y equals -1, if I just wanted to isolate the x, what would you do? You would add y to both sides, and then you would have x is equal to y minus 1, or it could be x is equal to -1 plus y. One of those things would come true. Now if you did it the other way around, so x minus y equals -1, and you wanted to isolate the y, all right, I'm going to have to 1 subtract x from both sides. Let me just move this down for a second. I'm going to move the x from both sides so that I have now -y is equal to -x minus 1. And now that negative sign, I'm going to have to divide it by -1. That's the tricky part. And that means I'm also going to have to divide all this by -1 so that I would have a positive x. All right, so negative x divided by -1 is just going to give me a positive x. And -1 divided by -1 is just going to give me a positive 1. So y equals x plus 1. So these are the two things that can happen. All right, so now looking at the steps here, do any of them match? The very first one matches. X equals y minus 1, which is exactly what we had here. These two wouldn't work because I can't substitute. I'm not doing any substitution. The first thing I would have to do is set it to either x is equal to y, x equals or y equals. So forget 3 and 4. And so why doesn't number 2 work? Y equals x minus 1, because just mathematically that's not what I was getting. I would get when I would divide it by -1, I would end up getting x plus 1. So that's why that one doesn't work. All right, and now the last one is actually my favorite, is dimensional analysis, because this one doesn't really require math. It just requires us to know when we're dividing a unit by unit, something by itself, we get 1. So what I mean by this, let's look what they want here. In 2009, Usain Bolt, a sprinter from Jamaica, set the world record in the 100-meter dash with a time of 9.58 seconds. His approximate speed in kilometers per hour can be found using what? So I want kilometers over hours. This is what we want to happen. So I'm going to just use the units here to kind of just space them out. I'm going to show you with number 1, and then I'm just going to do it faster with the other ones. So I have seconds times meters times minutes times hours. Already huge red flag, because I want my hours on the bottom and they're up here. That's going to kind of be my first signal. And then I have meters times kilometers times seconds times minutes. All I'm doing is rewriting this without the numbers. And now look and see, do you notice which ones I can actually would just turn into 1? So a meter divided by a meter, that's like 1. So I can cross that out. A second and a second, so if I have one on top, one on the bottom, I can cross those out. And minutes and minutes. So this one would leave me with hours over kilometers. Looks like what I want, but it's reversed. Because I want kilometers per hour, not hours per kilometer. That is why I will cross out 1. So do you see what we're doing there? I'm just laying out, I'm just looking at the actual units and crossing out. So now with number 2, if you want to write the whole thing out, you can, but I'm going to show you how you could also just look and see. Like I have here, meters times seconds times meters times minutes. Here I have seconds. Oops, so I have seconds and seconds. So I'm just going to cross those out. Seconds and seconds. Then the next one I have is minutes, so I can cross out minutes and minutes. And then I have kilometers. I don't have kilometers on top, and I have hours. I don't have hours on top. So with this one, I'm going to be left with meters times meters over kilometers times hours, or meters squared kilometers times hours. That's not what I want either. So now we'll do the same thing with 3. Just look to see, do you notice a unit that's on the top and bottom? Yep, I see meters and meters. I see, do you see anything else? I see minutes and minutes. And that's it. So what am I left with? I'm left with on the top kilometers times hours over seconds times seconds, or kilometers per hour seconds squared. And that's not what I want. So now we're up to the last one. Look and see, what do you notice? Let's see, I have meters times meters. I have seconds times seconds, seconds over seconds. I have minutes over minutes. And that's going to leave me with just 2 left. It leaves me with kilometers over hours, which is what I want. And that is why 4 is the answer. So this one is actually, it always looks super complicated. It looks like a lot, visually overwhelming, super easy to do. All right, that's the last of the multiple choice questions. Hit pause and jot this down into your notes and count up how many points you would have gotten for part 1 of the August 2025 Regents. Now we're up to the part 2 section, which is the open response. This is the part where I see a lot of kids who are nervous or who have been confused in math for a while. They kind of just look at these problems and they skip it and they don't really try. Like, they do at least pick something from multiple choice, but they're afraid to actually go into these sections. And I highly want to advise against that, because you may know something. Even if you don't get the full answer, there's always an opportunity to get some points. So for this one, we are solving an equation algebraically. We have 1/6 times 4x plus 12 is equal to 9. And we're just going to solve this for x. I'm going to use don't call me after midnight as always to solve, because in the beginning it's going to have the steps I need. So I'm going to distribute, I'm going to combine my like terms. If I need to, we're going to move a variable. I don't need to because I only have x on one side, so this is a step we're probably going to end up skipping. We're going to add or subtract to make a zero pair. We're going to add or subtract a constant, and then we're going to multiply or divide the coefficient. All right, and that's going to be to isolate the variable. Okay, so these are just my 5 steps to help me walk through it. I like this way more than just saying PEMDAS. All right, so we're going to start by just distributing, meaning I'm just going to multiply by 1/6. And here I have 4x over 6 plus 12 over 6 is equal to 9. All right, so now I can just simplify this out. I have 6x plus 2 is equal to 9. I don't have to move anything. I can now add or subtract. So my constant, so I'm going to subtract, so I get a zero pair, and I'm going to subtract here. So 6x is equal to 7. And for this one, because I want to isolate my variable, I could either divide by 6 and do 7, and this is where the choice comes in. I could either do 7 divided by 6, or I can multiply this by 6/4, and I can multiply this by 6/4. Which would you rather do? Would you rather multiply or divide? I like multiplying with fractions more. So I'm going to multiply by the reciprocal, so this just becomes x. Why? Because I have 24 over 24, which is the same as 1x. And on the other side, I have 7 times 6/4, which is the same as 42 over 4. And you could always simplify that out with your calculator if you need to. 42 divided by 4 is equal to 10.5. This is one way to actually solve this and get x is equal to 10.5. Hit pause and jot this down. And now I'm going to show you another way you could do this without the distributing. Let's erase all this. Okay, and this is just convention. I know that this entire thing is being multiplied by 1/6, this entire thing. So what I could do is I could just multiply this by its reciprocal and this by its reciprocal. That way, all I'm left with is 1 times 4x plus 12, or just 4x plus 12 on this side. And then on the other side, oops, I put 6 times 6 over 1. And over here, I'm doing times 6 over 1, or just 54. Okay, so all I did was I just multiplied it by the reciprocal here, and I multiplied the same thing here. All right, and then I could just do the same steps I normally would do. I'm going to subtract 12 from both sides. So now I have 4x is equal to 42. And I'm going to divide both sides by 4. So again, x is equal to 10.5. So this also works. I will tell you this method only works if the entire expression is like this, where I have a fraction on the outside and the rest of my expression is in a parentheses. If this would have been written as 1/6 times 4x plus 12 minus 8, I would not be able to do that. Because here I would only be multiplying this section and the other one, and not and this 8. This 8 changes everything, so I can't do that. I'd have to just distribute. All right, so I just wanted to give you that as food for thought in case you also solve the problem this way. Hit pause and jot this down into your notes. Let's look at number 26, another 2-point problem. Is the sum, so if I were to add 3, square root 2, and 5, would I get a rational or irrational number? That's what they're asking. And I would need to be able to explain this. So just by looking at this, I know that I can't add these necessarily because these are not the same. And if I did, even if I used my so just looking at it this way, I know that when I try to add these, it's going to be a really funky number because I don't have whole numbers. I have this irrational number that's still going to be there. So I know this is going to be irrational. And you can even test this. My reasoning is I can't combine like terms. I can't combine the terms. My sum wouldn't be a ratio. Okay, so that's kind of what my reasoning is on this one. And you can kind of leave that in there. You could say it's irrational because the sum cannot be written as a ratio. So let's put that into a full sentence. The sum is irrational because the sum would not be written as a ratio. Now this kind of confirms it. Now if you weren't sure just by looking at it, this was my reasoning in my head and this is what I've written down. You could also just use your calculators to confirm this, and you can put 3 square root 2, move this over, plus 5. And when you enter it, you get a very funky number. You get 9.242640687. That is definitely an irrational number. It is a non-terminating, non-repeating number. I can't write this down as a fraction. I can't write it down that way because it's just irrational. So this is just, again, confirmation. If you were to try it on the calculator, and now my reasoning makes sense. The sum is not rational because the sum would not be written as a ratio. And if you wanted to, you could even put this in there and say 9.242640 and on. Irrational. And that would be enough to get me my 2 points. All right, hit pause and jot this down into your notes. Let's look at our next 2-point problem. Here they're just asking us to complete this graph. So you're going to get a point for having the complete graph, but we also have to make sure it's over the domains where x is greater, it can be exactly -4 to exactly 4. So it's telling me it's between there. So I'm looking when the x values are from -4 to +4 in terms of x values. Okay, so I can think about doing this 2 ways. One is by using my graphic calculator, and 2 is by using algebra. If you're doing it algebraically, you can just put in your x and y, and you can literally start from -4. Oops, let me make this 1. I don't have the most space. All the way until you get to 0, 1, 2, 3, 4. And we can find all of these coordinates, and we're just going to sub in the absolute value of x minus 2. So the absolute value. So if I, for example, did -4 minus 2, I would get -6. The absolute value of this would just be 6. And then the same thing, I'll keep going. -3 minus 2 would be -5. The absolute value would be 5. And I'll keep going. So I know the absolute value is going to be 4. If it was -1, the absolute value would be 3. And if it was 0, 0 minus 2 would be -2. The absolute value would be 2. Okay, and then it gets to the next ones where now my numbers are more positive. But I'm still subtracting. So for example, I would do 1 minus 2. So that would be -1, so the absolute value would be 1. 2 minus 2 is equal to 0. Absolute value would still be 0. 3 minus 2 would be 1, so +1. And 4 minus 2 would be 2. So here are all my coordinates. Now I would just graph these out. So from negative 4, 1, 2, 3, 4, I would get 6. 1, 2, 3, 4, 5, 6. And I know that my next one was going to be negative 3, 5, negative 2, 4, negative 1, 3, 0, 2, 3, 1, and then I would have, oops, so I would have my next one be 0, 2, 0, and now my next ones are going to start jumping up. That's where I made my little mistake here. This would be 1, 1, and then it goes down. Here's 2, 0, here's 3, 1, and here's 4, 2. And it stops right there. So I have all my little points, everything is graphed. I can see it perfectly. So that's one way you could do it. You can just graph the coordinates. The second way you can do it is you can just figure out the points on your calculator. You're going to go to y equals. To get to the absolute value, you're going to hit this button here for math, move over to numbers, and press 1 for abs. So that's for absolute value. And now you're just going to type in your x minus 2. And then you're going to graph it. And it's going to give you the full graph, which is great. It's super helpful. But then what you could also do is you can go into your table and you can find all those points from negative 4 when x is negative 4, so I can move up. So we want negative 4, and here are the same points. So 6, 5, 4, 3, 2, 1, and 0, 1, 2. So from negative 4 to 4, all those points are there. Either way, you can place them. I like having all the points written out, and then you actually have to show that you can graph them. So here's my coordinates, and here's my graph. And that's how I would get my 2 points. All right, just look out to make sure that while you're graphing, you make sure you have your x and y coordinates correct. Hit pause and jot this down into your notes. Now we're up to a two-way data table for this 2-point problem. We need to be able to fill this out based on the information in the problem. They're not going to give us everything. We're going to have to figure a few things out. And this is definitely made up of, they're going to give us the parts, which is either adults or teenagers, and this would be the whole over here. So definitely thinking about the whole relationships like we did with fractions, like we did with percents. Same thing can happen up here where we talk about the 2 brands. Those are the parts, and this part being the whole piece. All right, so let's see what we got. A survey was given to 180 cell phone owners about the brand. So that's my total, about the brand of phone they own. The results show that 59 adults own brand B and 32 teenagers own brand A. So I'm gonna put those in. Those 59 adults owned B. So I'm gonna put it here because they're adults who own B. And they're telling us that 32 teenagers owned A. So again, teenagers, brand A. Of all the people surveyed, 40% owned brand A. So we're gonna put this, of all people surveyed, 40% owned brand A. So that would have to be both teenagers and adults. Okay, so where do I put that? So I want teenagers and adults. So here's brand A. So if I add both of these up together to get a total, I know that this is going to be 40% of whatever the other number is. So that's going to be important. So we're going to figure that out. Matter of fact, I don't want to put it there. I'm going to figure out, let's write it here, 40% liked A. Complete the two-way frequency table. So 40% of everyone liked A. That means 60% liked B. So there's some logic in there. What else can I figure out? Okay. So all together, we need to come up and figure out how many people there were. We know there were 180 people in all. So out of A and B all together, that was 180. So what we're going to do is we're going to figure out what is 40% of 180 and what is 60% of 180. To do that, I'm going to do 0.4. I'm just turning 40% to a decimal, and I'm going to multiply that by 180. 0.4 times 180 gives me 72. So that means 72 teenagers and adults liked brand A. Now, we can do the same thing for brand B. So we can do 0.6 times 180. So 0.6 times 180, and we get 108. And we could also check 72 plus 108 should give us 180. So 72 plus 108 does give us 180. So we're good here. So these numbers, pretty valid. So now that I know this, let's just look here at this part. If I take the adults and add the teenagers, I'm going to get 72. So adults plus the 32 teenagers gives me 72. I'm going to subtract 32 from both. X is equal to 40. So 40 adults like brand A. And we could do the same thing brand B. 59 plus Y is equal to 108. So let's subtract 59 from both. Y is equal to 108 minus 59, 49. So 49 teenagers like brand B. So now that we know that, we can figure out how many, like for this one here, what is the total number of adults? The total number of adults. So I'm just going to add these two together. 40 plus 59 is going to give us 99. Same thing here. How many teenagers? What's the total amount of teenagers? So 32 plus 49 is going to give me 81. And now everything is complete and everything adds up. So if you add it here, 40 plus 32 gives us 72. 59 plus 49 gives us 108. 99 plus 81 does give us 180. So everything adds up when I go horizontally, vertically. And now we could do the same thing horizontally. 49 plus 59 gives us 99. 32 plus 49 gives us 108. And 72 plus 108 does give us 180. And that's it. And this is how we use our logic. They'll give us part of the numbers and we use what we know to figure out the other numbers. All right, hit pause and self-grade yourself. See, would you have gotten all 2 points? Is everything correct on your end? And if you had a mistake, make the correction so you get a total number of points. Let's move on to number 29, which is another 2-point problem. We have a sequence in this one, a geometric sequence. And our goal is to determine the 8th term in the geometric sequence, whose first term is 5, and the common ratio is 3. So in other words, my sequence is starting with 5. I need to know this 8th term. So this is the first, second, third, fourth, fifth, sixth, seventh, and 8th. And they're telling me that my common ratio is 3. In other words, my pattern is going to increase by multiples of 3. So for example, if I start with 5, 5 times 3 is going to give me 15. If I multiply 15 by 3, I'm going to get 45. And my job is to figure out what is the 8th term. Again, there are 2 ways we can do this. The first way is literally just to continue out this sequence. This is the most accessible way, and you can use your calculator to do this. So you can do 45 times 3, and you're going to get 135. You can do 135 times 3, you're going to get 405, and you're going to do that again times 3, you'll get 1,215 times 3, and I'm going to put, let's actually put these numbers in there so we have them. 135, 405, 1,215, 3,645, and lastly, we're going to multiply the last one times 3, and we get 10,935. The eighth term in a geometric sequence starting with 5 and a ratio of 3 is 10,935. Okay, so I'm just going to erase that line there. So here we go. This would be my answer if I just did it this way. Matter of fact, it would be my answer if I do it the second way as well. The second way we could do it is by just using the formula for figuring out geometric sequences, and this is on your reference sheet. So we would have a to the n is equal to a1 times your ratio n minus 1. So n is the term that you want, and this is for geosequences. So you have to know how to use this if it's a geometric sequence, or if there's a different one if it's an arithmetic or an adding sequence. Okay, so if I want the eighth term, I'm going to take my first term, which is a1. So here's the first one, a1. So 5, and I'm going to multiply it by my common ratio. My spelling is just so off right now. My common ratio, which we know is 3. And then I'm going to do it to an exponent, to the 8th minus 1 power. So let's simplify that out. 5 times 3 to the 7th power. And we can do that just on our calculator. 5 times 3 to the, in this case I want to change this to the 7th power. Hit enter and you're going to get the same thing. 10,935. Okay, so that's it for this problem. Again, you just have to know the key parts for sequences, which is first, what kind of sequence is it? It's either going to be an adding or a multiplying. Do they give you information about the first term? And do they give you a common ratio? If they do, you can figure out any term in the pattern if you wanted to do it term by term, or if you wanted to use the actual formula. All right, hit pause and jot this down into your notes. See if you would have gotten a full 2 points. For either one, whichever strategy, this would be my answer. The eighth term in a geometric sequence starting with 5 and a ratio of 3 is 10,935. And my work shows how I calculated it. Whether it's this way or this way, my work would justify my answer. Hit pause and jot this down into your notes. All right, let's look at this 2-point problem. In this one, we're going to use completing the square. So we're going to use that method to express x squared plus 14x minus 28 equals 0 and rewrite it into this form, x minus p squared equals q. Now, this is a method for solving quadratics. It's one, completing the square is one that I didn't use a lot as a kid, and it's one of those things that I would just tend to forget because we wouldn't use it all the time. I did it a little bit in Algebra 2, but not much. So I'm going to show you the method that most teachers teach when they do this. And then I'm going to show you a visual method that helped me understand it in a way that made more sense. So first, when I'm thinking about x squared plus 14x minus 28 equals 0, I'm looking at it almost in this type of format where I have ax squared plus bx plus c, this type of form. And I want to rewrite it. It has to be when a is only equal to 1. So in other words, when I just have x squared, we're going to have plus bx and have the c on the other side. Okay, so that's kind of how we're writing out the form. And then what they're going to do is say, we're going to take, this is the part that I never used to remember. They will tell us to add b divided by 2, whatever this b term is, divided by 2 and square it to both sides. And so this never made a lot of sense to me. So in other words, I would have x squared plus 14x, and I would add the 28 to both sides. Okay, and now I'm going to do that thing I just told you that sounded strange, where now I'm going to have 14 divided by 2 squared. 14 divided by 2 is 7. 7 squared is equal to 49, right? And they're going to tell me, well, you're going to add that to both sides. So we do. And we end up with x squared plus 14x plus 49 is equal to 77. Okay? Then they're going to tell me now I can rewrite this into that other form that we know how to write. Pretty much we have x plus x, and because this is a squared, I have 7 times 7 makes 49, and I'm just going to put a plus in between them. So x squared plus x squared, x plus 7 times x plus 7 is equal to 77, or I can rewrite it as x plus 7 squared is equal to 77. Okay, so that's where we are right now in this work. I'm not the biggest fan of this one, to be honest, because that's all they wanted us to do was put it into this format. And I'm going to be super honest, I never used to remember all this. That a is equal to 1, that you had to add half of b squared to both sides. I would always forget that. So then I found this other way of thinking about it. If the first way makes sense to you, go ahead. Great. But I will get to this step. X squared plus 14x is equal to 28. And then it made me think, how would I complete this square? So the top square is easy. It's just x times x. Then I'm going to take this 14. I'm going to put half of it here. So I'm going to split that 14 in half. So 7 and 7. So it made me think kind of like this. Like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have 7 groups of 7 here. So what would I need to add here to complete the square? What would I need to add? And then I started thinking about it. I need 7 groups of 7 or 49. I need to add 49 to this. And once I saw that, I was like, oh, okay. Well, one, I know I'm adding 49 to both sides. So I know I'm getting my 77 here, but I can clearly see x plus 7, x plus 7. So I can see the x plus 7 squared is equal to 49. So for some reason, this made way more sense to me than looking at it the other way around. And I thought that was super interesting, that I couldn't always figure out what the rule was, but being able to understand that these rules come from something. These rules visually come from something very tangible that does make sense. It's just that sometimes we've forgotten what that is. So I'm going to hit pause there, and you can decide which method you want to use for completing the square. You can either use the visual drawing, or you can use the algebra method. Whichever one makes the most sense to you is the one that you can use. Hit pause and jot this down into your notes. All right, here we go. We're up to our part 4. Part 3, which has 4 questions in it that are worth 4 points. So 4 points, 4 credits, 4 questions, and this is in part 3. Here they're going to ask us to do more things. Like in part 2, they would just ask you 1 question, 1 thing to solve. And here they're asking us to do a few things. So for example, we need to be able to graph this function, we need to be able to state the vertex, and we need to state the equation of the axis of symmetry. Okay, so lots of different things. So we're going to start with the first one, which is just graphing the function. So I'm going to use my graphing calculator, and I'm just going to put in negative 1/3 x squared plus 4. So I'm just putting that equation in there. Let's graph it, and it's going to show me a picture of what my graph is supposed to look like. Now I like to then go and get my table so I can get the points that I really need. And let's see, so I like when x, so I want this easy point, 0, 4. I'm just putting xy. So 0, 4 is a very easy one for me to graph. Same thing with this one, negative 3, 1 is easy for me to graph. Like, I'm going for the easy ones. 3, 1 is easy for me to graph. And I'm looking down here, I have 6, negative 8. I bet if I would have gone up a little bit more, here we go. And I have negative 6, negative 8. Okay, so I'm just going to graph those 5 points so I have them. So 0, 4, so 0, 1, 2, 3, 4. Okay, that's the top. And then I'm going to put my other ones negative 3, 1. 1, 2, 3. Here's negative 3, 1. And 1, 2, 3. Positive 3, 1. And then I'm going to go and make the other ones. So 6, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to do the same thing on the other side. So 4, 5, 6. Okay, and you're just going to check to make sure that all of these make sense with your points. So just triple checking. So this is negative 3, 1. Actually, let me write it on the other side of it. Negative 3, 1. 1, 2, 3. Up 1. Yep. And positive 3. 1, 2, 3. Up 1. So we have those. And then down here, I'm just checking again to make sure. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So I have the same thing. So negative 6, negative 8. And checking the other one. And I'm doing this because I don't want to lose a point because I just graphed the point somewhere wrong. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Cool. Alright, now I'm just going to connect my points. I can clearly see that this is my vertex up on top. So I'm going to put that in. It's asking me now in the second part, state the vertex. And that point is at 0, 4. So that's all I need to put there. And now I need to state the equation for the axis of symmetry. So where this is my vertex, I'm just going straight down here. There's my axis of symmetry. And it happens when x is equal to 0. So that's all I need to write. At that point, that creates that line for my axis of symmetry. And that's it. So this one, pretty simple. I just need to be able to graph it correctly. Notice how meticulous I was about where those points were. And then be able to show that I know what a vertex is and what an axis of symmetry is, which is a very simple equation. Hit pause and jot this down into your notes. Here's our second problem. We're 4 points. We're going to jump right in. Vince wants to rent a canoe while he's on vacation. The canoe rental charges $18 for the first hour and $7.50 for each additional hour. So this is the one time, and then here's where I see a rate. If Vince has $78 to spend, write an inequality in terms of X that models the situation. Okay, so I need an inequality for this. So I know he definitely has $78 to spend. Can he spend more or less than 78? He can be exactly 78, but he can't spend more than 78. So whatever I write on this side, it has to be less than or equal to 78. So that's the first part. Okay, so we know he pays $18 for the first hour, and then after that, he pays $7.50 for each additional hour. So I'm going to write it in that way where X is equal to the number of hours. Now they're asking me in the second part, because that's all I need to do there, algebraically determine the maximum number of hours he can rent the canoe. So I'm going to just put down my equation here. 18 plus 7.5x is less than or equal to 78. I'm going to subtract 18 from both sides to make a zero pair. So 6.5x is less than or equal to 60. Okay, now I'm going to divide by 7.5 so I can isolate my x, and 60 divided by 7.5 is equal to 8. So that's what 8 is equal to. These are the 8 additional hours. And this is where they kind of got a little tricky, right? Because we had to figure out what's the maximum number of hours. So he did the first hour, plus he got 8 additional hours. So altogether, he can go for 9 hours. The maximum number of hours is 9. Done. So that's the only part that got a little tricky in this, is because you had to remember that he paid for that first hour first, and then this part was everything else. These are the additional hours. So if you had only 8 as your answer, 8 hours, unfortunately you do have to lose a point there. But they want to check to make sure you had the right inequality, that you can solve for that x, they're looking for that, and then that you can identify what would be the total number of hours with that first hour being paid for. All right, hit pause and jot this down into your notes. All right, let's look here at this next one, and what we're trying to do is we have to graph a system of inequalities. So that's going to be our goal. Now, I have seen kids do this 2 ways. I've seen kids either just know by looking at the graph, I can graph this because of the equation, and I've seen kids just go straight to the graphing calculator. You could do either one. Because I like getting into the practices of seeing it, I'm going to look at my first equation, and we know what my slope is, which is -1/2, meaning I'm going to go down 1 and over 2, and I could see that my b, my intercept, is -3. So just doing that, I could just go down. Here's my b, my 0,3, and then I could just use my slope to tell me what my next things would be. Down 1 over 2, down 1 over 2, down 1 over 2, because my slope is -0.5. Down 1 over 2. So I could just do this and just continue drawing that line out. And I could do the same thing here. I'll just continue it in the other direction. And here's my line. Now, because it's underlined, I can actually make this a straight line. So this is y is greater than or equal to -1/2 x minus 3. And I know that I'm going to shade up for this one. Now, if that makes you, like, if you don't feel confident doing that by looking at your equation, you could just use your calculator for this. I will just go to my y equals, and I will just put in that equation, that expression. I'm just going to put -1/2 x, 1/2, there we go, x minus 3. And I just want to check, because this is supposed to be a negative, so I want to use the negative. Oops, sorry that it went down a little bit. So -1/2 x minus 3. There we go. And now I can graph it, and you can see that the lines do match. Not only that, if you went to the points and you went to second table, my intercept when x is equal to 0, my y is at -3. I put that point. And then when I went to my x equals 2, my y went to -4. And you can see that right here. Like, I went over to, here's 2, -4, and then here's 6, -5. There's 4, -5, and then I went to the next one, 6, 6. So my points do match is what I'm trying to say, that I have this one. So I could go back to my y equals, and I could also put in my second equation. The problem with this one is that it's not written in that y equals form. So I'm going to want to do a little bit of work to that. So let's fix that up. Y minus 2x is less than 5. So I'm going to add 2. Let me see. Yeah, I'm going to add 2x to both sides. So y is less than 2x plus 5. And I could do the same thing again, where my m I know is equal to 2, meaning I'm going to go up 2 over 1, up 2 over 1. And my b is equal to positive 5. So I could just go 1, 2, 3, 4, 5. And starting from here, go up 2 over 1, up 2 over 1. And finish out this line as well. I get a little meticulous, so I'm drawing my lines here. There. So I could do that, and here's my line. Now here's the thing though, for this one, this line has to be dashed. So that's my only issue with this, is that I need to have just dashes because it's not underlined. So I'm going to just draw the rest of the little ones here, and I'm going to draw dashes. Okay, and here's my equation. Y is less than 2x plus 5. So I'm going to go down on this line. So I want this part, and on the other one, I'm going up. So where do they interlap with each other? They interlap with each other here in this section. So this is where my solution is. So I'm going to put my big S there. And now I've actually graphed my system of equations. Again, if you get stuck on how to graph it, you could just go into your calculator. Here's 2x plus 5 graph, and you can see both of them in there as well. So for the bottom part, I just need to be able to state a coordinate that's in my solution set. So any place in here. So I'm going to go for an easy one, 0, 0. So I'm going to go with my very first one. I'm just going to substitute that in. So y is less than 2x plus 5. All right, so 0 is less than 2 times 0 plus 5. 0 is less than 5. That's a true statement. So it satisfies. Now I write the next one in. Y is greater than or equal to negative 1/2 x minus 3. So 0 is greater than or equal to negative 1/2 times 0. So that's just going to make 0 minus 3. So 0 is greater than negative 3. So that is also true. So now I've justified that this point is in the solution set. Okay, so lots of different things here. We had to be able to graph. We need to be able to identify where the solution set was. We had to pick a point and then use algebra to prove whether or not that point satisfies the inequality and would be a solution. Okay, hit pause and jot this down into your notes. So here's the last 4-point problem. I think this is one of the few years that they didn't do linear regression in the 4-point. It actually came up in the multiple choice. Usually it's very, very, very common. It's usually the last 4-point question. But here we are. In this one, they want us to use a quadratic formula to solve this quadratic. So notice we've already had to solve the quadratic with completing the square, and now they're also asking us to do it with the quadratic formula. The quadratic formula, as soon as you start writing it down, you're going to have, let's write it for ourselves, negative b plus or minus the square root of b squared minus 4ac all over 2a. When you look at this equation, x squared minus 6x plus 3 equals 0, you're going to look for your a, b, and c terms. Here, there's nothing in front, so our a is equal to 1. our B is -6, and our C is +3. So now I'm just going to go right back into this formula, and I'm just going to substitute. So for instead of -b, so if B is -6, my B is just going to be +6, so plus or minus the square root of B. So -6 times -6 is 36. Actually, let me put it in as the way we had it over here. So -6 squared minus 4 times 1 times 3. All over 2 times 1, because our A is equal to 1. So that's it. That's all I'm really doing here. Wherever I see an A, I'm just putting in a 1. Wherever I see a B, I'm putting a -6. And wherever we're seeing our C, we're writing a 3. Oops, I forgot to put, here was our other A, and here was our other A. Okay? And that's all there is to it. That's literally all I'm doing. So this was a -6, and I want it to be a -6. All right, so I want just you to see that that's literally all I'm doing. If it helps, I'll even highlight the stuff here so you can see it. Here are my B's, there are my A's, and here's my C. Okay? All right, so then you're just going to solve it out. -6 times a negative times -6 is just going to be +6, plus or minus the square root of 36 minus -4 times 1 is -4 times 3 is just going to be -12. All over 2. Give yourself some space while you're writing this out. It's just going to be the thing that's going to be helpful. Okay, and now I'm just going to solve what's inside. So I have 6 plus or minus 36 minus 12 is 24 over 2. I do want to work this part out in here because they do want us to put it into simplest radical form. So try and think, are there any square numbers in 24? Any square factors? Well, yeah, I can do 6 times 4. So that works. So let's move this over. So 6 plus or minus the square root of 6 times 4 over 2. Now I can work on that square number, and I know that square number is going to be 2. So I can end up with 6 plus or minus 2 square root 6 over 2. And I can leave my answer like this. This is fine. I can leave it just like this. That's all they really want us to do. Now, if you wanted to go further and you do 6 plus 2 square root 6, I still can't simplify that anymore. Like, I can't add those two. And so I can't do that, and then I can't divide it. And if you wrote 6 minus, same thing. So I can leave this as my final answer. All right, hit pause and jot this down into your notes. There are 4 points altogether, but you can see there are lots of very small places where people can make mistakes. They can make a mistake when we have a negative and a negative. They might make a mistake here with the sign. They might make a mistake with the sign here. So that's the most normal place where I see people make mistakes. But then the second one is, if you got to this point, you're so close, you just have to make sure you're writing in radical form, which means I need to actually check and see, are there any square factors in here. Now, if they say rounded to the nearest tenths or something, then, like, if they had an answer like that, then you can go in and you would actually have to do 2 square root 6 and find out what this part is, and then you can get what the actual answer would be on your calculator. But that's not what they asked for this time, and you would round it. All right. Hit pause and jot this down into your notes. This was the last 4-point problem. Okay, here we are at the very last problem. This is our 6-point problem. So lots of potential points available here if we're just working through our problem very carefully. So let's read it together and finish up. Cameron sold hot dogs and soda at a concession stand. He sold, I'm gonna make this in, I don't want that color. He sold a total of 25 items for $45. A hot dog sold for $2.25. A soda sold for $1.50. All prices include tax. So here's the first part. If X represents the number of hot dogs sold and Y the soda sold, write a systems of equations that models this. So if this is how many X is our hot dogs, Y is our soda, we know altogether he sold 25 items. So I'm going to translate as X plus Y is equal to 25. Those are the types of items. Now, I know that each hot dog is $2.25 and each soda is $1.50. And based on how many he sells, and we don't know how many they sell of each one, we know altogether he makes $45. So this will be my systems of equation. Now they're asking us to, in the second part, determine algebraically the number of hot dogs Cameron sold and the number of sodas he sold. Now you can decide which method you would rather use, but I think that this kind of sets us up very well for a substitution, where we can actually set it to X or Y. So I'm going to do that. I actually want to change the Y. So X plus Y is equal to 25. So I'm going to subtract the X over here. Let's move that one over, and then we'll subtract it here. So Y is equal to negative X plus 25. So I can go into that first equation. So I'm going to use this. Actually, I don't want to have that there because I don't want to get it confused with my systems of equations. So let's move this down. And I'm going to move this over. I'm going to move this. So Y is equal to 25 minus X. Let's do this nice and clean one. Y equals 25 minus X. So now I'm going to go to my other formula, 225X plus $1.50 Y. But instead of Y, I'm going to put 25 minus X is equal to 45. Now that I have that, I can actually distribute. So I'm going to have 225X plus $1.50 times 25. And that's going to be $37.50 plus minus $1.50X, because I'm distributing $1.50 times a negative Y. So that's going to be negative $1.50X is equal to 45. Now we're going to combine some like terms. So I have this one and I have this one. So 225 minus $1.50 is equal to 0.75. So, oops, change it back to my pen. 0.75x plus $37.50 is equal to $45. We're going to subtract the $37.50. So I'm going to get 0.75x is equal to 45 minus 37.50 is equal to 7.5. So this is going to be pretty easy. I'm actually just going to divide by 7.5, but I could actually see my answer is going to be X equals 10. So this is X equals 10. So that's just telling me the hot dogs. He sold 10 hot dogs. So now I need to figure out how many, I'm going to put this, hot dogs. But now I need to figure out how many sodas. So I'm going to go back to my original, one of the original equations. So let's go to X plus Y equals 25. If he sold 10 hot dogs, he had to sell 15 sodas. So Y is equal to 15. And this is a soda. Okay? So make sure that however you're writing this in, you're putting it into a nice, easy place so that someone else can follow along and find it, because it's not a lot of space. But here you can see how I worked through and found the 10 hot dogs. If you were a little stuck just on this step, like how did I get from here to here? Fine, you could just do 7.5 divided by 0.75 and you're still going to get the answer 10. But I have that in there. Okay? So, okay, let's go to the last part. A customer has $20 to spend at a concession stand. I need to figure out what is the maximum number of hot dogs he can purchase if he has 4 sodas. So I'm going to put in my formula, 225x that equation. I don't know how many hot dogs, but I do know how many sodas. And he has $20 to spend. So I'm going to, instead of using 45, I'm going to use 20. $1.50 times 4 is 6. I already did that on the calculator. And here's 225x plus 6. So I'm going to subtract 6 from both sides. And I get 225 is equal to 14. 225x is equal to 14. And now we're just going to divide by 225. So 14 divided by $2.25. X is equal to 6.222. The 2 is being repeated. So I can I buy 6.2 hot dogs? No. The most hot dogs I can buy is 6. So I need to be able to say that. The max hot dogs he can buy is 6. And I like to close that off so we can see. We can't buy 6 and apart hot dogs, but we can buy 6 full hot dogs. And that's it. That's our last problem on this exam. This was all from August. So check and see if you had all these different parts. They're going to look to see, did you have both equations for your system of equations? Did you successfully use a strategy to find what X and Y is? So they're looking for that and do all the work correct. So it's possible you can have the right strategy, but you may have made an error somewhere. So your X and Y might be right, but you'll get at least a point for the strategy. And then can you use the answer to figure out what if he spends $20, how many hot dogs would he actually buy? And then figure out how many whole number hot dogs, because that's what makes sense in this problem. That's it for this video. I hope you found this super helpful and that you're starting to see that this test is pretty predictable. A lot of the math we're doing is algebra work from school, but sometimes there's so many different strategies you can use. You don't have to always use the most complicated one. Just use the one that makes sense. That's it for today, and later on this weekend I'm also going to have the January 2026 exam, so you can use that for practicing as well. I'll see you next time, Math Marbles. Good luck on the Regents.